What is angular motion in human movement? An organism carries out several types of movements by combining two different types of motions: linear motion and angular motion. The angular motion refers to the kind of motion that a body experiences when it rotates a skeletal structure such as limbs or arms with respect to an axis of rotation. Different joints have a different range of angles that can be subtended. Every movement that occurs in our joints results from angular motion. For example, when animals walk, their knee joint helps to undergo a rotatory motion in the lower limbs, enabling the person or the animal to move. The joint here acts as an axis of rotation for the angular motion of the lower limb bones. Examples of angular motion in biomechanics. Such angular motions are visually observed and analyzed to have a better understanding of the kinematics of biomechanics. Angular motion can be observed easily in several biomechanical activities such as 1. Movement in the shoulder, elbow, and knee joints. In humans and animals, every movement that occurs in our ball and socket joint present in the shoulder, the elbow joint, and the knee joint covered by the kneecap involves the application of angular motion. The respective joints act as the axis of rotation or the pivot point for the attached limb. This enables us to use our hands, so various activities, and walk with our legs. 2. Movement in wrist joint. The angular motion taking place in the wrist joint, in which the wrist acts as the angle of rotation, enables us to carry out various activities like writing, picking up things, throwing objects, etc. The angular motion of wrists plays an important role in sports like cricket, baseball, etc., and also in various dance forms such as Kathak, Bharatanatyam, ballet, salsa, etc. 3. Movement in the neck. The neck joints enable us to move our hands both laterally and vertically. This movement also takes place due to the angular motion of the muscles present in our neck. In old age, these muscles get weakened, and I am not able to cover a large range of angles for rotation. For this reason, old people are not able to move their necks freely. Certain organisms like parrots and rabbits are able to rotate their head up to 180 degrees, i.e. take and rotate their head backward. 4. Movement of wings. The wings enable birds to fly. Angular motion plays a very important role in the movement of wings. Wings act like a lever that is attached to a hinge, i.e. the joint. The joint acts like a pivot point or axis of rotation for the wings. The angular range of a bird's wing depends on the species of the bird. Certain birds have a larger angular range than others. Usually larger birds have a limited range of angular movement. 5. Movement of tails. Certain animals such as monkeys, sloths, etc. use their tails to carry out several activities. The tail is attached to a joint and can rotate or move along the axis of the joint. The movement of the tail is associated with angular motion. Some animals use said tails to keep hanging on tree branches, to maintain their balance, swing from one tree to another, etc. What is the angular velocity in biomechanics? Angular velocity can be divided into two parts in biomechanics: angular velocity or instantaneous angular velocity. Average angular velocity gives us information about the time taken to cover through a certain level of angular displacement. Whereas, instantaneous angular velocity gives us information about the rate of spinning of the body at a given instant of time. To understand the difference between these two types of angular velocity, let us consider an example. Consider a tennis match. The average angular velocity of a player in a tennis match gives information about whether she would be able to hit the ball or not. Whereas, the instantaneous angular velocity of the player would give us information about how far and in which direction the ball is likely to travel after being hit by the player. Angular velocity plays a very important role in several sports activities which involve whole body rotations such as diving, gymnastics, ice skating, etc. The rate of spinning of the player, how the player lands, the angular range covered by the player, etc. is primarily determined by the angular velocity of the player. In animals also, their running speed, jumping level, swinging ability, etc. is determined by their angular velocity. We hope this post could give you the necessary information about the angular motion in biomechanics. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.